I'm Gerhard Lazu, and you're listening to Ship.Show, a podcast about ops, infrastructure, and application platforms. In today's episode, we have the pleasure of Audun Fougholt Strand, Principal Software Engineer at NAV.no, Norway's Labour and Welfare Administration. We will be talking about NACE.io, the application platform that runs on-prem as well as on the public cloud. Imagine hundreds of developers shipping, on an average day, 300 changes into a system which processes $100 million worth of transactions on a quiet week. And if you think this is hard, consider the context. A government institution which must comply with all laws and regulations. Big thanks to our partners Fastly and Fly. This MP3 is served with minimum latency from the Fastly Edge location, which is closest to you. Our app and database run on Fly.io because it keeps things simple.
This episode is brought to you by SourceGraph. With the launch of their Code Insights product, teams can now track what really matters in their code base. Code Insights instantly transforms their code base into a queryable database to create visual dashboards in seconds. And I'm here with Joel Kortler, the product manager of Code Insights for SourceGraph. Joel, the way teams can use Code Insights seems to pretty much be limitless, but a particular problem every engineering team has is tracking versions of languages or packages. How big of a deal is it actually to track versions for teams?
Yeah, it's a big deal for a couple of reasons. The first is, of course, just compatibility. You don't want things to break when you're testing locally or to break on your CI systems or test systems. You need to have some sort of level of version unification and minimum version supported, and all of that needs to be compatible forward. But the other thing we learned was that for a lot of customers, especially engineering organizations that are pretty established, they have older versions of things, or even older versions of SaaS tools they don't use anymore that they haven't fully removed because they're not sure if it's still in use, or they lost focus on that. And they're spinning up old virtual machines that they're still paying for, or they're using old SaaS subscriptions they're afraid to cancel because they're not sure if anyone's actually using it. And so getting off of those versions not just saves you the headaches and the risks and the vulnerabilities of being on old versions, but also literally the money of older systems running more slowly, or the build times, or virtual machines and SaaS tools that you're no longer using. Before you had this ability, we talked to teams, there are basically three ways you could do this. You could Slack 1 million people and ask for just an update point in time. You could have sort of one human in one spreadsheet where it's somebody's job every Friday or every 2 weeks to just search all the code and find all the versions and write it down in a Google Sheet. Or there were a couple of companies that I came across with in-house systems that were sort of complicated. You had to know, maybe Kotlin, but you didn't know Kotlin. But if you wanted to use the system, you had to learn Kotlin, and you'd have to sort of build the whole world from scratch and run basically a tool like this with a pretty steep learning curve. And now for all three of those, you could replace it with a single line SourceGraph search, which is basically just the name of the thing you're trying to track and the version string in the right format. And then we have templates that'll help you get started if you're not sure what that format is. And then it'll automatically track all the different versions for you, both historically. So even if you start using it today, you can see your historical patterns. And then, of course, going forward.
Very cool. Thank you, Joel. So right now there is a treasure trove of insights just waiting for you, living inside your code base right now. Teams are tracking migrations, adoption, deprecations. They're detecting and tracking versions of languages and packages. They're removing or ensuring the removal of security vulnerabilities. They understand their code by team. They can track their code smells and health, and they can visualize configurations and services and so much more with Code Insights. A good next step is to go to about.sourcegraph.com/code-insights. See how other teams are using this awesome feature. Again, about.sourcegraph.com/code-insights. This link is in the show notes.
We are going to ship in 3, 2, 1.
I've heard about NACE.io, that's NAIS.io, an application infrastructure service built on Kubernetes from Vincent Ambo, our guest from episode 37. This application platform was built specifically to increase the rate of shipping code from a few times a week to hundreds of times each day. The surprising part is that this application platform is running Norway's welfare payments. So we are talking about many billions of dollars worth of transactions every year. It's huge. One of the masterminds behind it is joining us today to talk about it. Auden, welcome to Ship It.
Hi, thank you. Thanks for having me.
So who is the other mastermind behind this application platform? I know there's two of you.
The application platform there's a team, I think. So I think there's two of us working as principal engineers at NAV, but the application platform is built by a team. And I was a part of that team when I started, and then I worked there for 2 or 3 years full time, and now I'm more like everywhere in the company because there's so much things to do, and the application platform works so well. We need to fix all the other stuff.
But I know there's you and this other person. I've even seen your talks that talk about that. You're most the public figures when it comes to this, right? And the ones that have a lot to do with it. So who is your partner in crime?
Yeah. Oh yeah, his name is Truls Jørgensen. We had this big change of strategy in our company, NAV, 5 years ago, where we went from fully outsource to trying to insource and hire our own developers. And Truls was the first one, and I was the 6th or 7th one, I think. And now we are 300 or 400, depend a bit on what you count as a developer. But if you say product developers, I think we're up to 400 people.
That is a lot of people to be working on a lot of applications, on a lot of code, manage a lot of complexity. So before we started recording, you've described the two of you as Waldorf and Stadler, the two angry old men from the Muppet Show that constantly complain about everything. What is the most recent thing that you complained about?
Well, there's today we had a discussion about GDPR and Schrems 2, and it's easy to, although it's really important, sometimes it feels like there's so much. The technologists say something and the lawyers says another thing, and the trick is to balance the two out, and that's always difficult because a lot of the time one of the sides says, well, everything has to be like I say, but you have to balance the value of using cloud technology with the risk of privacy.
Yeah. And I'm assuming that running everything in-house is not an option.
No, well, we used to have that when we started. NICE first iteration of NICE was basically running on-prem. And then I think we have a strategy where we go quite slowly, both going from our old legacy systems to NICE, the Kubernetes platform, but at the same time also going quite slowly from on-prem to cloud. We don't want to do lift and shift. We want to modernize our applications and to get the full value of actually using Kubernetes, but also of using the cloud, because we don't see, well, there's not that much value to gain from just moving old stuff to new infrastructure. You need to modernize the applications and make better applications, because we always say there's none of the users of NAV care about their application platform. We're not here to make better application platforms. We're here to make better services. And better services comes from better applications. And then the platform can, of course, help with that, but that's not why NAV is NAV, to make application platforms. Although that would have been quite cool, actually.
So what is the difference between NAV and NACE?
Well, NAV is the biggest governmental agency in Norway. We have, as you mentioned, we pay out about 1/3 of the federal budget in Norway. We have everything from age-related pensions to parental benefits to sickness benefits, and we also have a responsibility of helping people get back into work and have the whole working system working as good as possible. So that's NAV, and we used to be many different organizations, and then we had a big merger in 2006 where the politicians thought that if you just put all these different organizations into one organization, then everybody will start to cooperate and data will flow between the different systems and everything. Turns out that wasn't as easy as just putting them into the same organization. There's still monolithic software causing problems, or 3 monoliths aren't necessarily better than 1 monolith. So we still have that. And so that's NAV. And NICE is basically our open source platform that we started building in 2017, which was a kickstart of the whole insourcing process where we thought that we should, because when we go from none or almost none developers and want to hire a lot, we needed to make it visible and clear that being a developer in our company is good. it's possible to work with good technology and have development speed and have all the good things. So we used it as a branding exercise as well as a technology platform to help us get people or developers in.
So 5 years, well, 2016, 6 years almost now, it will be since NACE has been around. What are the benefits that you've seen in this time of having NACE?
I think there's multiple. Maybe the clearest one is what you said before. We used to deploy at nighttime and have manual testing periods, and so deployments was maybe something that happened. 2005 or 6 it was 4 times a year, and then it grew very slowly. But it was always coordinated, always the big releases. But what NICE did was make it possible for the teams to handle this whole process themselves, and they didn't have to do. There was no technical reason from the platform or infrastructure side that made it necessary for them to coordinate with anyone when they wanted to deploy. Of course, there might be dependencies between applications, but that's a different thing to fix. So we're up to 1,500 releases a week. We've been quite steady on that for a few years, I think. We have about 1,400 applications. So it's on average there's 1 deployment per application per week, but we have some data showing that most of the deploys comes from a smaller part of the applications. There's a few of the applications that change a lot and some that hardly changes at all. And I think that's a logical consequence of doing microservices, because some is more support and some is more core. But the other side, which is, I think have taken me a bit by surprise, is the fact that we have this platform which has very, you can say it has quite tight entry conditions. Although we say it's only Docker containers, but we say you have to be stateless so we can deploy, because Kubernetes can move your application, and we do log collection this way and metrics this way and alerts this way. It's quite unifying. We try to do what Spotify called kind of making a golden path, to make it easy to do it the right way. And that works almost too well. We have almost all the teams do almost everything the same way. And so we have, although we say there's no real guardrails on programming language, for instance, or stuff like that, people tend to, they copy from each other and learn from each other, so it's quite unified how we do development. And we have a limited number of external services that's available through NICE. We have Postgres and Kafka, and that means that Postgres and Kafka are basically the 2 most important architectural part of our relation database, and we have event streams of events, and that makes it, that drives the technology development in a quite clear direction, I would say. We have a quite consistent architecture, and I thought that almost the opposite would happen, because you can do whatever programming language you want. The organization is so big and there's so many different problems to solve. I thought the diversity would almost be bigger, but it turns out it's quite unified, our architecture, and I think that's a good thing. Although I'm always a bit scared of what that means. If I don't want us to relax either, I want us to be able to see when there's new interesting stuff happening that we need to use.
Yeah. Okay. So going back to how many deploys you do, there's data.nav.no, and I'll put a link in the show notes, that shows how these deploys have changed over the years. And I think it starts in 2009. So there's a lot of data, 13 years worth of data, to see how many services you had, how often you deploy. That is so insightful. I was surprised that this data is public, by the way. This is amazing for anyone to see just, how big this platform is in terms of applications, in terms of deploys. That was really interesting. So I have to ask this, why Kubernetes? What drove you to Kubernetes?
Well, I think there's 2 answers to this. It's kind of the one, when we look back on it, I think we want to use open source technology. We want to have, although it's not important for us to use many clouds at the same time. We think that probably costs more than it gives. But to have kind of to use open source as the main, or open source APIs as the main boundary between the application and the platform, makes it easier to move and makes a better distinction between the application and the platform. So Kubernetes, when I started to make application platforms in 2014, Mesos was the thing. So we used Mesos and Marathon. I can't even remember all the things we used, but it was kind of a completely different platform. And we had the problems of they weren't cooperating well. There was just a bunch of open source projects, and you had to spend a lot of time just updating everything and figuring out how to use them. And then at that time, I think 0.8 or something of Kubernetes was released, and someone in our team knew someone from Google and said, well, this is good. So we looked at it, and it did all the things good that the Mesos universe did badly. Everything was one big package. You just had to figure out how this worked, and then it solved everything. So after that, it feels like Kubernetes basically won that space. And then all the cloud vendors came running or offered that as a service as well. So I think there doesn't seem to be that many alternatives that are as open source. You could go all the way to some kind of serverless thing and then be more cloud dependent, but I'm not sure I see that as a good move at least not for organizations of our size.
Yeah, that's right. Okay. So I'm looking at NAV.io and I see a lot of great components there. Grafana, InfluxDB, Linkerd. A few that I do not recognize. There's Collide with a K, OS Query, Unleash. How close are you to those components?
They're different things. Unleash is a feature toggle system. It was it was created initially in the company I worked for before NAV, a company called Finn, which is basically Norwegian eBay. And it's now a big open source project. I think it's one of the two big players in the feature toggle system. So a lot of our teams needs feature toggles to be able to handle their deployment speed. And then Collide and OS Query is part of a feature we developed quite late in NICE, where it's more about controlling the laptops we use and how the laptops connect to our clusters. So we call that NICE device, and Collide is basically it's a hosted service that glues together OS Query, which is an agent that runs on the laptop and checks if everything is up to date and the laptop is sound, and handles the management of that and how to communicate with users, telling them, well, you need to update macOS or you need to do a Chrome upgrade. And then we build some gateways ourselves that kind of does the last bit, so we can control exactly how our laptops access our production environments.
Interesting. So which of these components do you use most often? Because there's quite a few and it's not an exhaustive list. Is there something that you use on a daily basis? I'm assuming Collide and OS Query, because that must be running on your laptop. But what else that is more like you're more like hands-on, you're more aware that is there? Because I think Collide and OS Query, you install them, they provide connectivity, and they just kind of get out of the way.
I would say my favorite tool of all the tools of NICE is probably Grafana.
Really? Okay.
Ever since I used to be a backend developer making applications, and just the sheer joy and all the interesting things you get out of looking into what happens in production and making graphs of everything and trying to figure out why stuff is happening and what does this mean when this goes up and this goes down. And whenever at least when I was a application developer, whenever I didn't know what to do, I could always find something to measure and try to get more insight into what's actually happening in our application. Interestingly, we kind of, as a platform at least, or as a company, we moved a bit away, or not, we've extended how we do that. So now we're also more into getting the data out of the databases as well, trying to think of that data as a product and not just do the real-time monitoring, but also try to do more aggregated monitoring or reports even. So it's kind of a sister platform of NICE, our data platform called NADA, which we kind of try to do that with. So help the teams to be even more conscious of all the data they have and what they can learn from looking at the data.
Did you say nada?
Yeah.
Like nothing?
Yeah.
That means nothing. Okay. That's an interesting name.
The reason for that name, at least my version of the history of the reason of that name, is that we didn't want the platform to own the data. We wanted because traditionally the data warehouse is a central team, and the data warehouse team owns both the platform and the data. But we wanted to do the same thing with NICE, because NICE doesn't own the applications running on them, and we wanted the data platform that's a platform, and the teams should own the data. The application teams should own the data. So basically the NAV.no name is also it's NAV data, of course, so it's but we wanted it to be clear that the platform is a platform and the teams own the data.
Okay, that's a good one. So I know that you run other services, other components, as you call them, which are not listed on the NICE.io website. There's a tweet which I noticed 3 hours ago, very recent. Do you know what's cool? Keeping your Kubernetes cluster secure. At NAV.no, we use Kyverno to ensure no pod runs unchecked. And the question is, what is your best tip securing Kubernetes clusters? We want to hear. I'll put a link in the tweet. I mean, when this comes out, if you want to answer, it will be, a few weeks later, but still, it will be around. What do you think about Kyverno, and how do you think about securing things? Because this must be a very important topic, considering the data and the transactions and what is happening in your applications.
I would say answering that question from a more of a top-down perspective. First, I think the main thing with security, when you're making an application platforms and you want to help the team secure their applications, it's really important to understand the needs of the developers, to make sure that any security feature you add is usable. Because in my experience, there's been loads of security people that are so into security that they make this principle that is almost impossible to adhere to. So at some time in the process, there will be something where the developer has to choose, should I follow the principle or should I deliver on time? Most of the time, they will deliver on time. So you have to make the security things easy to use. In my experience, it's more important that it's usable than it's 100% secure. Because if you make all the principles and all the things that needed to make it 100% secure, and the teams doesn't follow that because it's impossible, then you have the worst situation at all when there's the people responsible for security think everything is okay. And the people in the teams doesn't want to tell the security team what they haven't done. So, for instance, we used service mesh. Before, we used to have these network zones in our on-prem architecture where we had two zones, one for the internal applications and one for the external applications, and basically perimeter safety. So if you came inside the firewall, you had access to everything. But instead, we used service mesh and zero trust principles to basically put a small firewall around every application and make it the team's responsibility of configuring this firewall. So the teams it's a part of the configuration of the application, what applications can talk to you and what applications do you need to talk to. So instead of a central firewall and some kind of person in the middle that's always have too much to do, you make it a team's responsibility to configure this, and then everything works better.
This episode is brought to you by our friends at Raygun. Get instant visibility into the health of your software, actionable, real-time insights into the quality and the performance of your web and mobile apps. And I'm here with John Daniel Trask, co-founder and CEO of Raygun. JD, how does the interface of Raygun help a team see progress? Because sometimes progress is better than simply goals. The goal is to have high-performing software, of course, but the progress to get there is not easily measured or celebrated along the way.
Yeah, this is something that I often find I end up speaking with more at the executive level with some customers, because it's also important to remind folks that aren't necessarily software engineers that, bugs are common. It's not the team's fault that there are bugs. And that's where we go back to the trajectory thing. Like, are we actually making progress? So sometimes the work we're doing with folks, we present like an error inbox where we group things up. so that you're not having to deal with every single instance. You can work at the sort of root cause level. And so that just looks really familiar, almost a little bit like Gmail, but you've got some charts, some beautiful attractive charts that will show you how you're going. It could be an engineering manager, it could be a QA lead, it could be anybody that can kind of say, look, the chart is going down towards the right. That's what we want to be doing. Less errors, or we want to get the response times up. Similarly, you want to make sure that you're presenting that data in the most scientific way. So no averages, just use medians, P99s. I want to understand the outliers, averages are just lies. So get the real data, understand where you are, and just start chipping away at it.
Very cool. Thank you, JD. All right, head to raygun.com to learn more and start your free 14-day trial. No credit card required. Join thousands of customer-centric software teams who use Raygun every single day to deliver flawless experiences to their customers. Again, raygun.com.
What about the data? How do you secure the stateful data that is persisted at rest? PostgreSQL, for example, or anything else that you use like for persistence. Flat files, maybe you have those as well. I don't know.
Well, there isn't one way we're doing it because we're so big and we have a gazillion different requirements. But for Postgres, we used NICE now runs on GCP. So we basically used the managed GCP service for Postgres, and we considered to bring our own key architectures, but right now it feels like that increases the risk of us losing the key more and thus losing the data than actually losing the data. So although that's something we consistently rethink, right now we mostly use the normal features of GCP, and then we have some extra backup things because we want to make sure we have everything running inside Norway as well, or have the data accessible inside Norway.
Right. Okay, that makes sense. Do you make use of anything like eBPF to secure, or at least have visibility all the way down into system calls, not just like network traffic?
I know the plan is for us to, I'm not entirely sure right now, but our plan is to go to Cilium as a service mesh from Linkerd. We were first on Istio, and then Istio felt like it was a bit too much for our needs, and then we went to Linkerd, and now we're looking at Cilium, which is eBPF. So I think, but that's how we approach that problem.
That's interesting. It's great that using a platform that promotes open source and has a very rich ecosystem, it allows you without too much investment to be able to go from one provider to another, or from one solution to another, which, by the way, there's open source versions of it. You can try it out. There's paid for versions. So it's nice that you can switch between these things. How did that work out for you in practice? How did it work out for you going from Istio to Linkerd? Was that, would you say, a seamless migration or transition, or were there complications that you couldn't foresee?
First of all, I just wanted to say we blogged about that. There's a blog which I presume you can put in the show notes after. I wasn't the main part of that process, but as far as I can tell, it wasn't that difficult. It took some time because you had to change something in all the applications, but we have a really good dev environment that we can do these things in. And I think, as far as I remember, it was something you did in approximately one day, moving all the several hundred applications from one to another. But
that's impressive.
Yeah. And I think more or less going all the way back to the questions you had about why Kubernetes, one of the main reasons Kubernetes is so good is you have this API, which is incredibly well thought through. And they made this in, 2015 or something, and it still kind of makes sense as an API, even though they changed a lot of the things behind it, and they made it extensible. But you have this API that's so good, and it matches so well with what an application and an infrastructure does. So it makes it possible to create tools like a service mesh, and it makes it possible to change implementations even of the service mesh, or the implementation of the Docker runtime or the container runtime or whatever, with almost no disruptions to the actual users of the platform. And I remember in the old days, most of the things was almost impossible and took weeks and months to plan and do.
Yeah, that's right. Yeah, I remember the pain. It was like so hard. Like you wouldn't even think like, no, too expensive. Let's just not do that. And that's how like a lot of the great ideas would end up because the implementation was just not worth it.
And now you can even buy it hosted. So most of the stuff you don't even have to think about, like updating or changing nodes or increasing the capacity. It's not even clicking a button.
Yeah, that's amazing. I love that part too. So if anyone is curious to learn more about this platform, there is some great content on docs.nace.io. There's references with diagrams, there's step-by-step guides, there's even 300 lines of YAML for the nice application example. There's a lot of Kubernetes YAML, best practices and other content worth reading. I enjoy digging into the deploy section. I was really surprised. There's like so much good stuff there. So have a look if you're curious. We'll add the link in the show notes, but it's docs.nace.io. So before we change subjects, there's something that I wanted to ask you since the beginning. I know that you've been in tech for quite a few decades. So how long has it been that you've been in tech? Do you remember when you started?
I left university in 2003, I think. So I basically been working. I started as a consultant, and then I realized consultancy isn't what I want to do. I want to be part of the company that owns the product. So, well, it's almost 20 years. Yeah.
Okay. So in a few sentences, as a very brief summary, what were the last 10 years in tech? What were your last 10 years in tech? There was Kubernetes part of it, but what else happened that brought you to where you are today, a principal engineer at NAV?
Well, I used to be a Java developer. I really identified as a Java developer, and a bit by chance, I got the role as a lead developer for the infrastructure and operations teams at one company, and then I realized I could use all the experience I had as a frustrated backend developer to make application platforms. And basically, I've been doing a lot of that since then, just figuring out, doing all the things I learned or I couldn't do easy before, trying to make that possible. And then for the last few years, it's been more and more about making everything fit together, not just the application platform, but making the management understand what's important and why making software is completely different from doing other things that the Norwegian government does and finances, for instance.
Yeah, that's right. So if you were to write an application today, would you still pick Java?
No, I would probably do Kotlin. I think I don't program as much as I want to anymore, but mostly I program in Kotlin and Golang. And I think programming Kotlin is more fun. But I might think that, and programming in Golang is a bit frustrating, but it feels like it will last longer and be stable for longer.
I see.
And so if it's my decision, I would probably still go for Kotlin because that's more fun, and you can feel more clever when you write Kotlin than when you write Golang.
Okay, that's a good one. And if you were to choose where to run this application, what would your choice be?
Nice, probably. I mostly write things for NAV, and then the question is similar. But I've always thought I mostly worked at big companies with hundreds of developers, and I have this lingering thing in my head where maybe all the things I think is good for those companies might not be good for small companies. So probably try to figure out some other ways of doing it, more serverless or more higher level abstractions from some of the cloud vendors, for instance, just to make sure. I have this suspicion that at some point in the future, that's going to be even easier, even for the big organizations, but I'm not necessarily sure we're there yet, but it's difficult to say.
Okay. So the last few years have been really challenging for governments around the world, especially welfare systems around the world. And we're talking about COVID, about the pandemic. It's been really, really tough. So what challenges did COVID bring for your platform, for NACE?
The very first challenge was, I think this was the 10th or 11th of March in 2020.
That's very specific. Okay, This has got to be good. All right.
Because that's when basically the Prime Minister of Norway said, well, everybody has to stay at home. And unless you have a really good reason to, basically if you're a fireman or work at a hospital or something, you have to work from home. Before that, most people went to the office most days, and all the tech and all the infrastructure was basically built around that. So luckily we had just enough, we had the necessary things to be able to start working from home, but it was kind of a challenge, and you had to relearn how to communicate and how to work as a team, basically. And I think that was interesting. It worked quite well when everybody was at home, and I think it's an even more interesting challenge now when some people want to stay home and some people want to go to the office, because it's much more difficult to solve this challenge when the teams are more hybrid. But that wasn't the most difficult thing that happened during the pandemic, because of this order from the Prime Minister. We had a lot of, and I think the English word here is furloughed. We had a lot of workers in Norway, not at NAV, but in Norway, furloughed. And according to the rules of Norway, then you're supposed to get a benefit. I think there's around 1,000 of those applications a day, and now we had like several 100,000 furloughed people in a week or so. So we were still early in our transformation then, so most of those applications would normally be handled by manual caseworkers. So our estimates was this: it's going to take a year for us to handle, in the current systems, to handle all of these applications before everybody get their money, and people needed money. So the government of Norway tried to make some alternative ways of handling this. So they had a list of 12 different things, I think, and me and a team, and Truls and others, started working on one of them, where we wanted to kind of have at the same time, we wanted to make the laws describing this benefit, which basically was an advance of the normal unemployment benefit. So we had to make the law, and then we had to make the system that implemented that law. And we had to do it really quickly. So I still remember we had stand-up meetings at 8 o'clock in the morning, 4 o'clock in the afternoon, and 10 o'clock at night. Every day for 2 weeks or something, where we tried to figure out what we could put in the law, because that was limited by what is smart to put in the law and what we could implement. So we had to balance kind of what's possible to implement in a week or so, and what's necessary to put in the law to reduce the risk of people misusing this opportunity. So
that's amazing. And this is a country we're talking about. This is not like a big tech company. This is like you're dealing with the benefits of a whole country, right? Like that's like your responsibility. Wow, that is big.
So we had the law was ready on a Thursday, I think, and then we managed to build the system in basically 3 days. And I'm really proud to say we built that system using pair programming, and we had the user testing late Sunday night, and then we went live on, I can't remember if it was the Monday or the Tuesday, and then we had a gradual rollout using Unleash actually. So we could make sure that the system kind of worked while we had the increased pressure. And then in a week, we had paid out 1 billion Norwegian kroner. A week from the law was ready till we had a 1 billion Norwegian kroner paid out.
Okay, that was a good system. What did you write it in by any chance? Was it Kotlin?
This was Kotlin. Kotlin
Really?
Running on nice and a Postgres database, but
Wow.
it was a lot of reuse. We had some strange components. We had the calculator that was people used to figure out what they could get in a benefit if they needed to. But that calculator kind of had the functionality we needed to get the data to calculate what the people should get in these new benefits. So basically you used the calculator as an API. So we kind of grabbed things from everywhere, and the payment system had this old file-based interface that we used. So instead of, we had some of the integrations was like totally modern with Kafka and asynchronous. Another one was writing files to disk and a bash script moving that file to another disk.
That's crazy.
And then the payment system picking up the file and putting it into making payments. So it was everything. We took whatever we could find, basically.
Lots of respect to the people that built that, because as cobbled together as it was, it worked, right? Are we talking billions, like with a big B? Well, 1 billion krona, I'm pretty sure it's like at least as much as like $1 billion.
No, I think it's a tenth. Yeah, I think $1 is 10 Norwegian kroner, but still, it's loads of money in Norway.
Right. So just 100 million, right? Like in a week, just $100 million. That's okay. Like some bash scripts and some Kotlin and some like Postgres and some Kafka. That's just amazing. And it all worked. Okay. And how long have you been using that system for?
Well, of course, when we built it, we said, well, this isn't going to last long. And I think we turned it off a few months ago.
Okay. It served its purpose. Wow. Okay. Sometimes you just like have to make it work. And that's all the time that you have. So it's not like we'll ship it next week. It's not an option, especially if like the prime minister says, okay, a week from now, those payments will start going out. You have to deliver. Wow. That's amazing. Do you imagine that being a success story if you didn't have the platform that you had at the time? Can you imagine like making it work without it?
Not in the time frame, and maybe not as secure, because we could probably make something like that work quickly, but then we would have to build even more stuff. And in that time frame, the less you have to build, the better, because you're bound to make mistakes and cut corners and everything when you have to do things that quickly. So the more things you could use that are hardened and works, the better. So I think the security part is probably what we earn or what we got from using the platform.
How many people were involved in this project in that 1 week?
I think we were maybe 20 people. I think we had around 10 developers and lawyers and everything.
Wow, okay. That's amazing.
And we had this was one of the things we had to make. We had I think Norway had a 12-point plan or something, and NAV implemented a few of them, and then other parts of the government implemented the rest of them.
So today, how many developers are working on the platform and using the platform? I think you mentioned 400 roughly.
We have 400 in-source developers, and then we have a few hundred consultants as well. So I think we're up to 600-700 product developers at NAV in big. I think we have 800 seats on GitHub.
But, wow, that's a big org. Okay.
Yeah.
Okay. And how are they structured? Like, how many teams do you have, or do you even have teams?
Yeah, we have teams. We have. Well, it kind of depends. I think we have about 100 actual teams doing product development, and then we have some management structures and everything. That kind of are teams, but not that kind of teams. And as we're that big, we try to organize even more. So we have what we call product areas, where we kind of divide NAV into some teams work with the work stuff, and some people work with the health stuff, and some people work with the family benefits. So we need to split NAV up into smaller parts for it to be comprehensible.
Okay, it makes sense. I mean, there's like a lot of people obviously organizing that and being aware what everyone does, and not duplicating efforts. Like, I did this way and you did that way. Okay, we have to reconcile all that good stuff. I'm wondering just how big is this platform in terms of resources? I'm thinking CPUs, memory, things like that.
Well, at least our production cluster running in GCP has 50 nodes, which is a total of almost 800 virtual CPUs and 1.6 terabytes of memory.
Wow.
So
that is a big cluster. Okay.
And we have our architecture is one big cluster instead of multiple small ones. It's kind of a religious question, I think.
How are we finding that configuration, having one big cluster versus a couple of smaller ones?
Well, of course, we do divide this. We have namespaces for each teams and stuff. So the question is probably, do you want to have more separation? But I find that it's easier to manage one cluster, although lately we've been working more on making it possible to make more clusters, because we're experimenting with providing nice clusters to other governmental agencies as well in Norway. And to be able to do that, we have to automate, or making it more robust and more automated, the process of making new clusters, because we want the different other companies to have their own clusters and other setups.
Mm-hmm. One thing which I remember when we were using Kubernetes, I mean, again, the scale was very different, but upgrades sometimes, wouldn't go as smoothly. And then what do you do? What do you do if you have a single cluster that you do an in-place upgrade that doesn't go out so smoothly? Like, some component doesn't interact well with other components. What do you do then? Did you have any such problems in the past?
We had more problems, or maybe not problems, it was more work when it was on-prem. But this, I think, is one of the good things of the managed service. Google does everything for us. So either we decide when to do it manually, and which is probably for major upgrades. If minor upgrades, it's just a maintenance window, and it kind of happens. And I think one of the reasons it's important for us to modernize the applications before we migrate to Kubernetes is then these kind of operations becomes easier as well, because if the application is robust enough to be able to handle that the node dies because it's moved to another node, then upgrading the cluster is also much easier.
Okay, I see. That makes sense. Especially if the applications are stateless and you can run more than one instance, then, you have reduced capacity for a while. But then if you have nice, you're basically draining a node, the application knows to spin extra, instances somewhere else, and that's okay. It's like minimal disruption. It's no different to a scale up in a way.
And it's no different to a deployment or whatever. So I think that's one of the, again, the value for this, for our sake, is better applications. That's the core value of doing all of this.
So you've been using GCP for a few years now. How was it like in practice to use them?
Well, I think before we went too far into the cloud journey, we kind of had we checked the different cloud vendors, at least the three big ones. We realized Alibaba isn't for us right now, so it's basically Azure, AWS, or GCP. Yeah. And then we looked a bit at the offerings, and we focused mostly on hosted Kubernetes because we knew that was the big thing we had. And especially at the time, I think this was 2019, the difference in quality was quite big. I think they're closer now. I probably think it would be a closer, more different or more difficult comparison now. But at that time, it felt like Google had by far the best hosted Kubernetes, which kind of makes sense because they're the biggest, or they're the fathers of Kubernetes. So yeah.
Yeah, I know what you mean. Do you feel like there's something missing in GCP? Something that you would want to have?
We're quite conservative in what we use. So I'm not really sure. As I said, we want to focus on using open source components, or at least the APIs of open source components. There seems to be a trend where the cloud vendors say, well, this database is Postgres compatible, but we won't tell you what's behind. And that's kind of okay. But as long as we want to use open source APIs and open source components, the number of services we use are quite small. So I'm not really sure. We could probably get, Kafka, for instance, we're buying from a different vendor, running on GCP, but we're buying it from a company called Avon, which is a Finnish company hosting open source databases. So yeah, and that's not really a problem, but we're quite conservative in the technologies we use, so I'm not really sure I can answer what I need other than more open source, Elastic and Kafka and everything, but Avon gives us that.
I think that's a good strategy, right? The boring technology is what you would want to have, considering the stability that you require, right? Like, you don't want to be on the cutting edge. You don't want to be trying things out. You want to go with a proven, tested, reliable software that is open source, preferably, so that if you want to, or if you need to make a change, you can contribute that. And something that you can trust that will be around for the next 10, 20 years, right? Ideally, at least.
Yeah, because we know startup, and basically, we're not in a competitive marketplace. We're part of the nation. So we have systems not running on NICE, but mainframe systems that are 40 years old. I'm not necessarily sure that the code we write now will run for 40 years, but the problem we're solving is going to be needed to be solved for many, many decades to come. So it's better to spend some more time doing it properly now than trying to redo everything every 50 years because we hurried when we started.
That's right. So are there any migration plans for the older services that have been around for decades?
Yeah, but then again, we're basically rewriting everything. That's not true. For some of the systems, we're rewriting them. For some of them, we're looking into more different migration strategies. Like, I didn't know this was possible before, but you can take COBOL code and translate it into Java. Really strange. I looked at the Java, it looks really strange, but it looks like COBOL, but it is Java. And then you can run it on normal servers. And then you can reduce the cost of the infrastructure quite a lot, because mainframes are really expensive and Linux servers aren't. So, but of course there's risks involved, because we have systems that has to work and you're making it run on a new technology. But our main strategy is to basically recreate the products that run on the old systems on new architecture and build them again with teams, and basically try to frame the problems within organization that can live as long as the problems needs to be solved. Because I think the biggest thing is to have the teams knowing the domain, not having the systems being able to solve it, because because of the time frame we're working in.
And what would like a COBOL job ad even look like these days? Like, where would you find those people? Like, that would be really, really hard. Okay.
One could imagine that, because as far as I understand, there's loads of important stuff running on COBOL in the world.
Yeah.
And a lot of the people who wrote them and know COBOL is getting old and ready for retirement. So at some point, I presume it's going to be very lucrative to learn COBOL, because not everybody have the opportunities we have to modernize. So
yeah, that's true. That's a good point. Okay. COBOL on Kubernetes. Yeah. That is a startup idea right there.
Yeah. Well, I always, when we started introducing Kubernetes, I think I had the argument at least 5 different times of how Kubernetes is basically exactly like the mainframe. And there's obvious similarities, but it's also the clear differences.
Okay. What does a good day for Auden look like?
Yeah, that's a really good question. I had a really good summer holiday.
Okay.
The funniest thing in the world is to code.
Mm-hmm.
But then again, whenever I'm coding, I realize there's, at least most of the time, there's bigger problems that needs to be solved to make it fun to code. And I spent a lot of my time trying to fix the big problems and then hoping at some point we can code again. But of course, it's also important to code. So I try to, or me and Truls and a few other people, we try to code a bit every week. And then the important thing is to find the things you can make that aren't important. That's valuable, but not important, because sometimes we haven't got the time to deliver. We can't promise when anything will be finished, but it's fun to make things that people like. So trying to find kind of the small things. Right now we are working on trying to take the application configuration in NICE, the NICE YAML file, which basically says what applications do you need access to and what applications have access to you, and what Kafka topics do you need to write or read access to. And take this information out of the cluster and make a visualization of all the applications and who talks to who. And that's fun, and I think it's going to be useful, but no one's asked for it, so no one can tell us we're late.
Well, as you know, a lot of the time, it's the ideas or the things that no one asks for that's proved to be the game-changing ones. Like, no one needs this until, like, how did we live without it? Like, we need, like, everyone needs that. So, and
just the other thing that's part of a really good day is when we manage to get all the other disciplines of NAV to understand, or that we learn something that's important for them, the lawyers or the management or whatever, and they also understand a bit more about what's important to do, what's the important frameworks to have in place to do modern software development. That's not necessarily the same as running other parts of the government, because the soft part of software makes everything a bit different.
Yeah, for sure. So talking about frameworks, I know that you mentioned security a few times. I've seen a blog post about SALSA. Where do you stand on the whole supply chain security, the SALSA model, things like that?
Well, I think it's, at least for us, it was an important next step. I think you're kind of building blocks from kind of the basic stuff, and then you go further up and you realize there's always more problems to solve, and to be able to, when we open source and when we trust the teams as much as we do, it's important to make the systems that can basically prove that the trust we've given them was okay. That we can say, well, we can see that this happened from that team, and we know that this is okay. And for instance, when Log4Shell came, and although we managed to get a handle on it, there was obvious that we could have responded even quicker by saying, well, what applications are affected by this? And to automate that, this kind of feels like the next big thing, or the next thing at least. One of the next things. There's always multiple things.
So is there something more significant than this that you're working on in the context of NAV? Something that is important to you?
Well, the one thing that I mentioned a bit, trying to see if we can make nice and platform for more than NAV, because I think we're one of the biggest organizations in Norway, and we have 25 people working on platforms, and some of the smaller government agencies maybe have 10 developers, and there's no reason to believe that they have the capacity to make as good a platform or think through enough of the security aspect as good as we do. So if you can manage to make that possible for them and help them as well, I think that's a really good for Norway. I know the UK had something similar with Go.uk. They had this platform as a service. I think they had almost 30 different organizations running on this central platform.
Yes,
and
yes, that's right. AlphaGov, I remember that. Yeah, I haven't checked it recently to see where they are at now, but I remember that. That was a very interesting model. I know that the US government was doing something similar, and that was like a reference at the time. That was many years ago, 5, 6, maybe more. Okay. Was that by any chance an inspiration for NAV?
Well, one thing we really learned from Gov.uk was the open sourcing. I remember reading the principles on open sourcing from Go.uk, and basically, well, we started translating it, we realized we could just link to it and say, we agree totally with this.
Yeah.
So, and basically because of that, I think we open source almost all the code we write, not just the application platform, but everything we write at NAV is almost everything is open source, except for like fraud detection and some experiments with the laws that aren't finished yet, and of course some security aspects like passwords and everything. Most of the code we write now is open source.
Mm-hmm. Do you find that other people contribute to that or comment? Like, what is the interaction with that open source code from the public?
Most of the interaction and most of the use of the open source platform is like kind of obscure libraries. So that we have one small, I think, Kubernetes operator that talks to Azure AD, which is used by multiple companies. And then you have a Kafka testing library that someone used, but it turns out that there aren't much of a market for open source unemployment benefit systems, for instance.
Right, I see what you mean. Okay. So not much competition there.
No.
Okay.
So it's more about openness than about people. And we think that people we code or implement the laws that are public, so the code should be open and public as well.
Yeah, that's right. Do you find it helps when it comes to hiring, when it comes to recruiting?
Yeah, absolutely. I think it feels like a value proposition that software developers really like, that we say, well, we do it, we code open.
You're attracting a certain type of developer. I think it's very good to have. Okay. Are there any talks that you or someone else from your team gave recently that you would like us to link in the show notes?
Truls and I was at QCon in London in May, talking about about NICE and how we do technical governance, basically. That's probably the best one for an international audience.
Is it public, the talk?
I think so. There's InfoQ and QCon. If it isn't public, I think it's going to be public at some point, but I'm not entirely sure when. Okay,
I'll check it out. Okay. I know that you have a very good blog, the nice.io blog. There's a post on Salsa. There's a few others. I think you mentioned about service meshes. There's a post there too. I really like it. I mean, there's not too many posts there, so it doesn't feel overwhelming. But what is there, it's like very compressed. It's very good, like the learnings from this, or this is what we're thinking about that. And there's not a lot, but it's very valuable. I found it just like browsing through it.
The newest post is about Elm as a front-end platform, so kind of the application front-end framework. So the application platform concept is kind of a bit stretched now.
Okay. So as we are preparing to wrap this conversation up, is there a takeaway that you'd like our listeners to have from today?
I think for big organizations, I think an application platform is really valuable. And I think the main thing to think about when you make application platforms is to treat the internal developers of your company as users and basically make an application platform the same way as you make an application. Do experiments and think of the product and try to figure out how can you solve the problems of your users and then solve them.
Yeah. And write good docs. Like the docs, Nace.io, they're really, really good. There's so much good stuff there. I really like that. Okay.
I haven't written any of it because I'm not a good writer. I think I have one chapter somewhere in there, but most of it is written by other people. But I agree, it's really good.
All right. Any shout outs that you want to give to anyone from NICE, from NAV, people that you work with that, are doing amazing work and you want to give a shout out to them?
No, maybe I think the shout out could maybe go to our NAV IKT GitHub profile, where you see all the other open source code, not just NICE. I think that's a good place to start.
Okay, excellent. Right, Odin. Well, I had a lot of fun today. Thank you very much for sharing so many amazing things with us, and I'm looking forward to next time. Thank you.
Thank you.
Thank you for tuning into another episode of Ship It. Check out our other podcasts for developers at changelog.com/master. You can connect with like-minded developers via changelog.com/community. Thank you Fastly for the worldwide low-latency changelog.com. Our listeners love those blazing fast MP3s. Your Firecracker VMs and that WireGuard integration are really sweet, Flutter.io. That's it for this week. See you all next week when we'll be talking about developer experience infrastructure with Kenneth Orschenberg.